In this video, I'm going to show two different experiments, starting with this copper disc and then a steel puck later on, which has placed on it a coil of fiber optic cable. And I'm shining a laser into one end of it, and the coil is just sitting on top of the copper disc here. So if you watch carefully, you'll see how the weight changes when the light is on and when it's off. So these clips are running at 5 times speed, just to show the correlation more clearly between on and off and the results with the reading on the balance there. So I came up with this idea a couple years ago after learning about Louis Rancourt's work with light. This seems to be such a profound effect, though, that the coil on top, when it has light inside of it, causes, as it seems, the metal disc to move upwards. Of course, this is a very weak effect at this point here. It's somewhat crude, as you can see here. I'm trying to carefully shine the laser beam into the end of an optic fiber, which is a very small target. And I've since progressed past this with getting an actual glass fiber, and I'll be working with real optic fiber. These are just cheap plastic ones. So interestingly here, you can see the combination of the green and the red has a more apparent effect on the weight, the response there on the scale. And then it goes back towards 0 when I remove the light. Yeah, this particular setting on the balance, when the weight is changing pretty quickly, it tends to flicker around or fluctuate back and forth until it finds an average point. That can be changed in the settings, but in this case here, it's not. So there you can see quite a jump up to minus 0.082, and then back up towards 0.045. In other words, closer to 0. So now I'm going to change over to the steel puck now. The steel puck has a lot more matter in it. It's a lot more, just bigger. And I think that's important. I call it the optical warp coil. My balance has a limit of 200 grams, so I have to move the steel puck further away. Now you'll see quite a rapid change there. which looks greater than with the copper disc. So a minus 0.132 grams, which should go back up towards 0 now as it's relaxing in the ambient gravitational field. This can actually take quite some time for this relaxation to happen. But applying the laser again, you see a rapid change again towards a more negative weight. Minus 0.25. I'm not sure why in this case the bounce back towards 0 is not happening as much as with the copper. But it seems pretty clear that there is a relationship between applying the laser and the drop in weight. So once I can properly interface the laser to the optical fiber, I think that I will see more consistent results and be able to get more quantifiable data. I thought about patenting this technology, but I found out that it had already been disclosed elsewhere.
Another experiment